Hello and welcome to another video. And today we have a Prime A520MK on our bench. We have a letter included in it. It is written here in German. The board turns on, but no output on the video with doesn't matter what graphics card. No, he doesn't have a CPU with an integrated GPU. So yeah, sometimes it worked, sometimes it didn't. Okay, that's basically it. So let's see then what this board does for us here. If we, with our GPUs that have integrated graphics, if we might get a post out of this one. It's a nice decent board, Prime D550. So I wouldn't think that there's anything shorted on here, but we anyways going to test it out. So let's see now. So we check 3.3 volts, high resistance, 5 VSB, high resistance, 12 volts, high resistance, 5 volts, high resistance. Let's check the 12 volts for the CPU, high resistance, and the 12 volts to the phase. Let's see where we can. I need to probe it from the lower side then. Also high resistance. Okay. Let's check the BIOS battery, which probably has been replaced already. Yep, 3.05 volts. So that is also fine. So then let's get a CPU into here and see for the passive power consumption then. Because we have no major line shorts. So let's start with a 2200G I would want to start. So we install 1 stick of RAM. I get the DDR postcode analyzer in here. And let's also see, this probably should have a TPM header or something like that, where we can plug in the PCIe test card in. Let's see, does this have a TPM header? COM debug port. Yeah, this is an Asus, I remember. For Asus, we can use a flying line method with the COM debug port. I can show you that there. We can also make it different. Let's do it like that. That should work. Okay, let's also get a power button into here and a speaker. Okay, let's get power into here and let's see for its passive power consumption. 160 milliamps. That looks very fine. We have some back LEDs and we have, yeah, we would expect 130 milliamps, something around there, but with having LEDs, that looks fine. Let's see if we have a reaction to the power button and if we get anything out of this board. I'm gonna plug in a monitor already just to be sure. Post screen is active, so let's press the power button. And we have reaction to the power button. And we do get post codes. And this seems to be running. We have 2.3 amps. Oh, you can see it there. Right there. And there's a picture. So this just seems to be a BIOS problem. Nothing else. So let's just flash the BIOS ourselves. And I have another board of this viewer. So we will definitely continue the repairs. But this one seems to be working fine. Let me get a cooler onto here, with which I can flash the BIOS quickly. And then we will see if we can get into Windows. If that works, we're going to move on to the next motherboard. And currently I'm flashing the BIOS on here. And the BIOS is updated and it will reset. So after I've updated the BIOS now, I've now put in a 4100 to see that this board now can work with an external GPU, so not with the integrated one, and actually boot into Windows. And we can currently see, very good, we have changing amps. That is a very good sign, as I would expect it. And let's see if we get a picture now out of this graphics card. And let's see, is it going, it's probably complaining about the graphics card because it's a really old one. Let's let it restart a couple of times. And there's a picture. That is very good. So now I want to go into Windows, and when this went into Windows, we can certainly say that this was just a BIOS issue. Yeah, new CPU installed. Yeah, VGA card is not supported by UEFI driver. Yeah. No adjustment are needed. Go into the OS directly. So let's see for the boot manager for Windows. And let's go into there. And when we are on Windows, this board is basically done. So all this had was an incompatibility, probably with his CPU. This happens very, very often on AM4. Many people buy boards that are incompatible with the processors that just see AM4 sockets and they buy them. And they often have not the fitting BIOS on there. And on some of boards like this one, you will need an actual CPU in order to upgrade the BIOS, because there's no BIOS flashback or something similar like that on this board. So, and often people then have either stuck CPU LEDs, they sometimes have stuck VGA LEDs, and all it needs is a BIOS update. And in this case, it probably was something very similar. This is one of the reasons why you will need many different CPUs for AM4, because it just supports many different generations. And especially on some 500 series boards like X570 and B550 and similar, they often cut the support for CPUs that are lower than the 3000 series generation. So sometimes 2600, 2200G, something like that won't be supported. So that is very important to know. And Windows is doing some weird stuff. But yeah, let me get into Windows properly, get you once more into here, and then we're going to have a look at another board. And here the board is booted up to Windows, so let me get everything disassembled and let's get the next patient on our bench. So now we have the next board. This is an X570, if I'm not mistaken. Let's see. Strix X570F Gaming. It is written right there, down there. And this one is supposed to have heavy corrosion. Again, in German. Had this board, bought as functional. When it arrived, it was dead. The board didn't react to anything. He noticed multiple signs of corrosion. One chip on the left in the picture isn't properly attached, and more corrosion. Okay, and he included a picture of the SIO. So I've had a quick look at this, and the corrosion is pretty bad on this, and I don't know if we can fix that. We will have to look in the SIO area and in the area around the power button. So let me first show you the area of the SIO. So we can see pretty bad corrosion right here. And let's see. Okay. It seems to be still attached to whatever is here. Oh, no, it isn't. Yeah, here you can see it. This is lifting from there and there from the corrosion. There's a component missing right here. We probably have to replace all of these. We might be able to resolder this one. More corrosion up here. Let's see. The rest of the SIO, yeah, also small signs of corrosion. More here on this capacitor. But nothing down here where the audio is, so it seems to remain close to the SIO on the side. So the Ethernet chip here looks fine. So it seems to be we started somewhere here, right there, and went down here. And let's see. This doesn't have corrosion, but where definitely corrosion is around here. This is at the bottom. So this is a fan header. Let's see. But this USB port looks fine, this 3.01. Let's see here, there's more here. This is the power button area. And yeah. More damage around here. Okay, so we will focus upon the SIO area first, and then we will have a look in this area. So let's go to the SIO area. Let's... I first want to secure down that component, that we don't lose that. Because I want to get some brushing into here and some IPA in order to clean up this area. But I do not want to lose this component. The small passives are all non-relevant because I can replace those easily. But some of these transistors are very special. So let's see. And let's see. Very often what you have to do when you have this bad of corrosion is to scrape with your soldering iron. And depending on the flux you have, this works better or worse. So it should be secured down. Let's now get a lot of IPA and just clean out as much as we can here. And then we will have to get into a board view and see for what component is missing right there. And we might want to replace also some of the passives that are around here. So the area looks a lot better already. Let's now get some flux onto some of these points here. I want to resolder this transistor right here. And also this capacitor. The lower capacitor there is already gone. So that showed that that one was hanging on by a thread. Just like this one. This one was not attached anymore on this side. Let's try to clean off these pads. Because these pads are very corroded that are here. Yeah, the lower pad is gone. And I think that upper pad is also gone. So this is what corrosion does to a board if you just let it sit with that corrosion. Let's see, let's also get this resistor here. Let's, oh there, I can see the capacitor that I got knocked off. Right here. Oh, this is a resistor. This might be the resistor that was missing there. But we're going to get rid of it because it's very corroded. A resistor we can just replace. There is no problem with that. So, what I would want to try right here, let's just get hot air into here and reflow some of this area in order to see that things are properly connected. Yep, that cap is also gone. And that transistor. Yeah, those pads weren't holding anymore properly. Yeah, all of that is just... That is a big problem. These pads won't hold anymore properly. Because we tried to solder on top of corrosion, as you can see right there. And this is the big problem, that even if it looks like they are soldered. This is why corrosion damage is just... You cannot give warranty because stuff just falls off without you knowing it. So this pad was very corroded. Let's see, there's more here. And the question is, can we get solder back on that pad right there? Or if we have to rebuild that. So these two soldered on. And let's see if we can scrape away on these ones in order to get solder again onto them. And this is broken. There's no connection here anymore, I'm pretty sure. So we would probably have to run a jumper wire from there to here as well. This is the big problem with corrosion damage. Like this, for example. If we wouldn't have scraped this away, we wouldn't have seen that there's probably no connection between there and there anymore. That this is broken. So now it's slowly starting to look a little bit better. Let's see now if we can get solder onto these pads again. That holds solder now again. That also. These hold solder now. But this one at the top does not want to hold solder anymore. So we will probably have to bridge that as well. Oh, this is bad. But the transistors that we had before, they did fly away, but I still have them. So let's see which transistor sits where. This one's set to the left here. So let's see if we can get it tacked on a little bit, and then we're going to reflow it later. So get that tacked onto there. So now we have these components on here. And what we want to do, I'm going to go very low airflow with a little bit higher temperature. And let's try to reflow those components better into place. And then we will have to probably run some jumper wires next. There's not enough flux here. Let's get some more flux onto here. So, essentially the situation right now. This actually looked like this soldered on fine. We might have to see for this connection right here for that resistor that is fine. We have to run a trace from there to there. The top one didn't solder on properly, and there's two missing components here. This is basically what is now. So this was a big capacitor. Then was there a capacitor, I think, and that was a resistor here. Not too sure. We will have to check what was what. These are connected. These should be. And we will have to run a wire, as I said. And yeah, and then I think we can continue. So let's start with connecting these two. That tab has a connection to that capacitor, as you can see from that trace. So we can just bridge that. So we take some flux. And we see to bridge that contact. There it is. So that is connected. Now let's also reflow this here, just to be sure. And now let's run, we can check that with the multimeter first, just to be sure, but pretty sure there's no connection there anymore. So what we want is a connection from there to here. And there's nothing anymore, yeah. We will have to rebuild that trace. So I'm just going to take a thick wire here. And enamel, well, the enameling doesn't really matter because it's a very small space that we have to bridge here. And there it is. That is already the bridge done. Let's get this cut off here. Right there. And now let's clean up the area. And let's see if we have all of the connections that we need. So we now have our components back on here. Our transistors, we have that one trace rebuilt. And let's now see for the components that are still missing, the two capacitors and the one resistor presumably. Let's see in the board view what kind of values those are supposed to have. So this is a board view file of an X570-F, but it should be the same as you can see here. We have a linear regulator for the RTC section. And we have a capacitor right here. This is also a capacitor that we've seen. We've seen that 100k ohm resistor. And we've seen this be connected here. This is the trace that we put on there. So we need a 10k ohm resistor right here and a 1k ohm resistor right here. So we are missing these two. Let's put these two on. And then we might already want to see if this board behaves any differently. Or if we get a boot out of it or a reaction to the power button at all. So the upper resistor here is supposed to be a 10k ohm. So let's get a resistor into them. There's our resistor. What I always do is I tack on one of its sides. So we get some flux onto this side right there. I'm going to grab the resistor, place it in there, and solder it on right there. Right there. Doesn't want to move higher because of the solder pad that is there. That doesn't matter though. We just want at least one side tacked on. Let's get the 1K resistor that is supposed to be right below it. So let's now get the other one tagged on. So it needs to be on the same side. So one of these sides are connected, but the other one shouldn't be. Yeah, now one is connected, but the other one isn't. Yeah, now this is the point where it really shows that this pad was corroded badly, where it's really hard to solder to it, and solder doesn't want to stick to it. So now both are there. Now we want to get them into place, and I always do that with hot air. So let's hot air them into place. And now that should be fine. Now let's clean up that area. So I'm currently not too happy with how this turned out. It should be fine, but I would want a little bit more solder on both sides of the lower resistor. Let me get a finer tip. So now it should definitely be soldered on here. And that should also be fine. So, looking at our area, we have two rebuilt resistors. We have this rebuilt track. Theoretically, there should be a capacitor here, but we might be fine without that capacitor, but we will have to see. This is now connected there. These are resoldered after they have been kind of knocked off from the corrosion. I hope that this is also fine now and that this actually connects now. Let's go with some checks of continuity just to be sure. So from here to there we have connection, that is good. From there to there we have connection. From there to there we have a connection. Let's now go into resistance mode. We go from there to here, which should be about 10k ohms. Yep. And from here to here, we should get 1k ohm, which we have. So, all of that seems to be there. So, after having rebuilt this, let's now try to go in the overhead view, see for some resistances, and then see if we have a reaction to the power button. So let's see for resistances. 3.3 volts. Seems to have high resistance. That is good. Yeah, high resistance. Let's see 5 VSB. Yep. 12 volts. Yep. 5 volts. Good. Let's see for the 12 volt of the CPU. High resistance. And 12 volts to the face. Also high resistance. Let's see for the voltage of the battery looks fine, a little over 3 volts. Whew. Let's then try a CPU in here. Let's get a 2200G. We're going to be putting in 1 stick of RAM. I know we still have the corrosion down there, but that might be just for auxiliary stuff that is not necessary for boot up. I first want to see if there's any reason even continuing with this board, if we can get a boot out of this. So let's see now, big moment. If we have actual some power consumption, we want to see about 130 milliamps. That looks very good. And let's now see with pressing the power button if we have a reaction. And nothing yet. Okay, we have no reaction to the power button. But what I want to see is if there's any sign of reaction if we short PS on here. So shorting PS on just gives a quick pulse. I was a little bit too hopeful here. We will have some more corrosion then, because I think the area that we have been working at should be fine about now. But let's double check that and go under the microscope once more. So let me reflow these resistors just to be sure here. I think they are fine, but I just want to be sure. Reflow them and yeah. So, I have now reflowed some of the resistors and now have a good look at the power consumption when I press the power button. 400 milliamps and instantly off. And now pressing the power button, nothing anymore. So only when resetting and turning it on again, let's see now. For a quick second, we get power consumption. So that indicates to me that there's probably something shorted on this board. That as soon as there's power consumption, that there's power in going in there, there's something actively shorted. So I will have to take off this cover and that cover in order to see for more corrosion down there, and then we will have to check this area in or if we have some short circuits down there. So everything is off. Let's see under the microscope again. So let's see first around the BIOS if we have any corrosion anywhere else. So around the BIOS looks clean. Nothing here. Let's see here now. This is the second area that had big signs of corrosion. And I think there might be their component missing. Oh, this is a headache. This is a headache. Let's see for the resistance here on that coil. Oh yeah, this is probably our problem. 7 ohms. Yup. So we will have to find out what is shorted on this power rail. There could be so many of these things could be shorted with how this looks like. So all of these are for fans, all of these here, and they could short the 12 volts. Let's see. But the 12 volts is not shorted. Okay, so let's inject 1 volt into here and see what is shorted on there. If it's the input side here or something on the output side here. Let's see now. So this should be a 3 volt one. I first, for the first time, try now with capturing through the PC software. Let's see now. Oh, 3 volts has, that is 8 amps of power consumption. So I think this might be our PCH that is dead here. That is not great to see. I will have to get this cover off of the PCH. So we can definitely see the PCH heating up. 1 amp of power consumption, but I'm not too sure if this is actually meaning that it's dead, to be honest. I think we have to desolder that. We have to desolder the inductor there in order to see on which side that is, or if we have a short somewhere else. Let's go under the microscope again and let's see a little bit how this area works. So this should be the input side of it. So this is probably the gate controller for these MOSFETs, the phase controller, that then controls these two MOSFETs, that then produces 1 volt right here. Let's see if these MOSFETs are still okay. Let's see, we are in continuity mode. Let's see. Yup. So we have continuity through this MOSFET up here. Interesting. So, and down here, we have no connection. So it seems like it might be that this transistor is shorted, because I get connection through these, and I don't think this is supposed to be like that. So just a quick editor's note. The resistance that we actually see there is between ground and the output of the PCA. That's why we see 6 ohms there. So it's not shorted, but the upper part of the MOSFET is connected to ground, and then we're just checking the phase to ground, which is 6 ohms, which why it seems that the MOSFET is shorted. So it's been about 2 days since I started this repair on this board, and this board has really been throwing me through a loop. It has changed behavior in between days of when I tried to test this, because the corrosion just keeps on giving here, and it is a problem that you cannot really deal with to the end. So the last thing that I wanted to talk about is this resistance down there. There's a buck converter right down here. Let's get that a little bit more in shot. Right there. There's a buck converter. Well, it's a phase controller. It's a phase controller that has 2 MOSFETs and an inductor. This inductor is the 1 volt line that goes into the PCH. That has to have low resistance. Let's check the resistance. So let's see. We have, as you can see, we have 6 ohms. That is very low resistance, but that is supposed to be for the 1 volt rail. And then what I was doing, because it still was kind of a suspect for me, that the board was quickly restarting or quickly shutting off. This has very often to do something with the PCH. On Z170, Z97, similar boards, Z370, and many Intel boards, there's a ME region, 105 volts for the PCH. Or just the general 105 volts for the PCH. If that isn't running, you very often have the case of quickly restarting 00 postcodes and similar stuff. And what I thought about to do is to take my lab bench power supply, take 1 volt added. So lab bench power supply, crocodile clips. 1 clip goes to ground. The other clip I connect to a tweezer. Now we get passive power consumption. So we see 160 milliamps. We connect now to that phase. I get 2 amps of power draw. Hit the power button and have a look at the power consumption. Do you see that? 2 amps, 2.2 amps. And LEDs. The post LEDs are running. Let me quickly get the post screen into here. This board is running now. We have the green LED. Means we're booting and we have picture. It is updating LED firmware. I have about 1.5 amps of power draw with the injected voltage that I have, which really isn't much. The PCH is getting hot, quite hot. So we want to turn this off now. And right there, it's restarting. We should get a new picture. There we are. But I want to turn it off right now because we do not have heat sinking on here. Even though it says don't turn off because of updating firmware, but we cannot do that with the PCH getting as hot as it was. So we will have to figure out why this 1.1 volt isn't running. And this is exactly the area of where we had corrosion. So what we will have to do is find out what is missing for creating that voltage. So let's go under the microscope then. So now we are easier able to talk about the topology. We have this phase controller. You have a upper MOSFET and a lower MOSFET from the phases. This one is connected to ground there, and this one is connected to the supply. I don't know what the supply is. It might be 12 volts in this case. But I'm not too sure. Maybe something. It's probably 3.3 volts that supply is connected. That is to ground, and then they switch on and off based on this one to create 1 volt at the output, and you smooth it with this inductor right here, and then you have the output. So we do not have a problem on the output side of things because when we inject voltage, there's no abnormal power draw, and it works. but we have a problem on the input side. So what I would mostly expect is that this controller has a problem with the amount of the soldering that is here, and I would also want to have a look at these capacitors or just resolder a whole bunch here. So with corrosion, first thing that you can do obviously is just clean it. So first step I want to do is just get a lot of IPA, and we are now going to be going to try to clean this area. Better would probably be white vinegar if I would get that, because that neutralizes this oxidation. But let's now just, for now, take IPA and scrub a good amount here. So the area is mostly clean now. This might already be enough, but it might also not be, because you could see stuff like this here. These capacitors here also have to be cleaned up, and we will have to check if any of these are shorted. So we will go into continuity mode, and then we will check how these behave. So let's go into continuity. One side is connected to ground right now, so one side should beep theoretically. So let's see now. That side beeps. This side does not beep. This side does not beep. That side beeps. Okay, so that's not shorted. Let's see now. This is ground. This side also beeps because there's the resistance of this inductor right here. Because on this inductor there's the 1 volt rail of the PCH. Let's see. This side, this might be ground, but it might not be. So if we have a short, no, we do not have a short, because one side is shorted but the other one is not. Okay, so there's no shorts here. The soldering looks to be fine for now. What we can do is we go over all of these components and give it a resolder, and we take off this chip and resolder it also. Big question is if any of this here is related to that power rail. Because if that is, we will have to clean this up also. So let me get some more just IPA and just clean up this area, see if any of the components fall off. Like, the area looks awful. There's probably this board will be able to turn on, but I wouldn't trust it, and I wouldn't want to sell it to anyone or like build it into a computer for anyone or something like that, because this board is just so far gone. Like, yeah, many things won't work, but I want to take this as a demonstration what is theoretically possible. Like, if you would be in a shop, you would never want to fix this, because you would have to give warranty onto this, and you do not want to give warranty on a job like this, because you're just asking for a warranty job to come back over and over again with different features not working, and just more unpaid labor for you. So it looks just a little bit better, not much, but some of the areas are a little bit better. And yeah. So what I think definitely needs resoldering in here, that might be related, is these two resistors might be, and that resistor needs to be resoldered. And then we have to look a little bit around what the inputs of this is. If we have to resolder something here, and maybe even the chip itself. So let's first resolder these two here and try to get them to a good connection. So again, what I would want to do is, if you have acidic flux, this would be very easy. If you, for example, use rosin flux, I think it's called, that would help a lot. But in my case, I do not. So let's just try with the soldering iron. Let's do that to that one more resistor also that is right here. So let's now take the hot air station and just reflow these. And I want to see good connection on them. Move them around a good amount. That looks good. Okay. That looks a lot better. And once more, just... So with a little bit of cleanup, I had another idea. This capacitor, this might be a bootstrapping capacitor or something similar. So I definitely would want this capacitor and that capacitor right there to have proper contact. So let's reflow those as well. So just for the heck of it, I just quickly reflowed a lot of things there. Just to be sure. Like, it doesn't look great, but we just want some contact here. Like the capacitor on the bottom, that filtering cap that you see, that looks just awful. Like that one. But it is connected, but just barely. So let's just see if that already has changed something for us. So let's go in the overhead view. Let's see now if we now get an actual boot out of this with just by itself. Nope, still the same happening. So it seems to be drawing very high amps for a very short second right here. Okay, then what we can check. I would want to lift the inductor from one side and see for the voltages of the left side of the inductor of the phase controller if anything changes. But first, let's go into the board view and see if we have similarities and if we can see what would be important here for the phase controller to actually work. So let's see here. This is our phase controller. This is an RT8125. Let's see. This has bootstrapping, one ohm resistor, and then a capacitor to ground probably. Or to its phase. Okay. So we have a 1 ohm resistor that needs to be there. Then we have that bootstrapping capacitor. Let's see, pin 2, U-gate. This just then goes through this 0 ohm resistor to that gate. So let's see, pin 3. That is the phase. That is probably like a feedback or something like that. That also feeds into here. Then the 4th is the lower gate. That is for the lower transistor. Then we have VCC. This is the incoming voltage. This is supposed to be 12 volts. So this thing is being fed via this 2.2 ohm resistor with 12 volts. We have an actual feedback pin with a lot of capacitors, but there should be 2 resistors. That is most importantly. This one, a 499 ohm, 1.87k, very specific value, and an 8.2k ohm resistor. Okay, it's very important that these all have good contact. Let's see, pin 7 is a comparator pin. These also need a proper connection with. This is connected to the feedback again. Okay, pin 8 is not used. 9 something related to an offset. Okay, and pin 10 is a ref. If it's an output ref voltage or something with the offset. Okay, so I do not see any connection to stuff on this side. And also on the output, we only get mostly stuff on the PCH itself. And we know that if you have an actual output, if you have the 1 volt connected to here, which we did, it is working fine. So there has to be something on this side right here. So what we also should try is to see if we have the what is the upper voltage? This one. we would need to find out farad bead. If this is okay and if we have 3 volts here, so this MOSFET can actually work, that would be important. And if this is not shorted because of this capacitor or whatever is there. And then we also have to make sure that all of these passives here and the controller itself makes good contact. So I would probably want to take off the controller, resolder all of its pads, and then also resolder the contacts of all of these passives around here. So let's try that, and then we might need either to change out the controller or desolder this one in order to check for some voltages. So let's resolder all of these passive components. So also this 0 ohm resistor, this low resistance resistor, this 2.2 ohm, and all of these here. So we're just making sure that everything contacts fine, because currently we have just a very hard time checking on this chip what is happening, because the board isn't turning on properly. So just trying to get some solder to all of these components, and then we will reflow them. Let's also get the solder pads look good for the resistors up there. But let's now get then hot air into here. We will reflow the passive components, and we will also instantly take off the controller that is on here. So the chip is off, the area is reflowed, basically everything is reflowed at that point with all of the hot air, but it's still missing these two. These two I forgot. These two resistors. Yeah, they're also reflown. So let's now get some leaded solder onto these pads here. Now we're going to be taking off the mixed solder that we have on here, and we're going to replace it with only leaded solder, so we have easier work. Now all of the pads are clean. Now we're just going to be applying some leaded solder right here. And what is important now, the chip that we have taken off, we want to solder and want to see for the solder that is on here. But the chip looks very clean from the bottom, to be honest. Let's clamp this chip and just with a good amount of flux just go over here. And what we want now is to also wick off most of it without losing the chip. So this should be fine now. Let's now try to resolder that chip onto here. So the chip is now there where it's supposed to be. We will have to hold the chip down at least a little bit, because it's going to fly away otherwise. Like that. So that should be fine already, but I want to get once more reflow that with a bigger amount of flux on here, just so that it goes into place properly. So now cleaning up, just a lot more of cotton buds, IPA, and scrubbing. So now basically everything is reflowed, everything has gotten something. The only thing I would want to check is if that bottom right is these pads, if they had something on them ever, but I don't think they would have. And yeah, let's just first now check if this turns on and this works now. So let's see now. Nope, still won't work. Too bad. So I've done quite some measurements, and I cannot get any further currently with this board. So what I will be trying to do, I have a replacement controller for that. And on a donor board, I will be desoldering that controller and resoldering another one onto there in hopes that that will clear out our problem. So let me do that. I will do that off camera, and let's see if that can fix our problem. So it still doesn't look clean, but that controller is a lot cleaner than the one that we had on there before. But I got to be honest, I don't have too much hope right here. So let's go into the overview and see now if that has worked for us. So passive power consumption and pressing the power button and nothing still. Okay, I think I'm going to call it on this board because I have checked so many things on that controller, and I want to show you something very interesting. If I connect the 1.1 volt myself, or the 1 volt myself right here, if we connect it here, turn on the board, now I'm going to take off the tweezers, and if we now probe the voltage, we do have the 1 volt just working fine. I do not know what is happening with this board. It just doesn't like being started up from scratch with this voltage. Like, the controller seems to be fine. There might be something related to the output capacitors, or it doesn't like the initial power draw on that. I just cannot tell you what the case is here. One more thing that we might be able to check is the resistance of that coil, if that has deteriorated maybe. But I cannot believe that is... No, the coil is totally fine. There's not an ohm of resistance there. So something on there is preventing it from starting up. I don't know if the current draw from the beginning is too high and then it only can soft start or anything. Like, everything looks fine. All of the... Like, the chip works, obviously. But something is still wrong. But I do not want to spend any more time on this board, because, as I said, this board is too far gone. There's too much damage, water damage done. There's damage around the socket. There's damage around the PCH. There's damage around the SIO. I just wanted to see if it would be possible to get this back to life. And most of the functions are there, but using this board is just asking for trouble. It's just really asking to have a bad time if you would put this into a PC, because the amount of corrosion that has been done here has just gone too far. So many of the pads where things are connected are corroded. There's no connection, or just a very weak connection. And over time, these would get worse. And especially also if you clean them, they also get worse. So a lot of things would need to have resoldering. It really sucks for this grade of a board, because this is a great X570F gaming from Asus. But it's just too far. Like, I could not feasibly sell this to anyone. Like, if you would be scummy, I could make this work, sell it to someone, and then after a month or something, it would deteriorate even further. Because as soon as you put voltage into something, the corrosion gets even worse. Because I think it was called electrolysis. Whatever. Electrolyse it is called in German. I cannot... Yeah, you know what I mean. And I think because of that, it would even get worse, the corrosion on here. So, it's been a few days again, and I wasn't happy with how I concluded the video. So, you didn't see that conclusion, but yeah, I recorded one and I wasn't happy with that. I want you to have a good look at how this board behaves now. We now are going to apply the 24-pin only with 5-volt dual. So we're going to be in standby mode. So have a look at the power consumption. We have 600 milliamps in standby mode, which we would think is way too much because there's something shorted or something like that. But what I want to show you is that we now have on that inductor 1.08 volts. So I've done it that this voltage is always running in standby mode. And now have a look at what happens when we press the power button. Now at the press of the power button, we now get an actual boot sequence. Now the board is actually in VGA and it's going to boot. So this way I made it that the 1 volt is not applied when we go into, what is it, S3 state I think it is, or S0, when the board is actually turned on, but in S5 state, which is the standby mode. So how did I do that? Let me show you under the micro. So this is our buck converter, and the buck converter was fed by 12 volts on that resistor right there. This resistor I connected, I desoldered that resistor from that pad, which is 12 volts. Then I fed this line to this capacitor right there. This capacitor is the high side of the phase of the MOSFET, which normally should be 3 volts, but I connected where the 3 volts comes in through this Farad bead, which is basically like a coil, something similar to that for filtering, goes into there, and it's normally 3 volts. And I connected that one on the other side of the board to this pin right there. And this pin is 5 volt dual VSB. So this is 5 volts in standby mode, which then feeds the high side MOSFET for being 5 volts and also the chip. So this way I was able to leave everything else the way it was, like they configured it, but I was able to get 5 volts dual into this phase to have it always running and outputting 1 volt. Because I didn't know, I just couldn't find the reason why this wasn't running as it should be in normal turn on mode. But like this, it would start. I still don't think this mainboard should be used, but theoretically it can be used. And the big thing is, I don't know if this has any repercussions for any other parts of the board when the 1 volt is always running. Like, if I would be deploying this board, I would always switch off my power supply then, so that the 5 volts, 5 VSB isn't running all the time and isn't feeding this voltage all the time. The 5 volt dual should be strong enough in order to feed this voltage, I think. I don't think that it would overload it. The power consumption is kind of high with 700 milliamps, but probably because some stuff about the PCH is already starting up at that point then. And other parts of the board are then probably enabled, which shouldn't be enabled at that point of the board. But I don't think that heat will be a problem with that anything would overheat, especially if we put all the coolers back onto here. I will be monitoring this under a thermal camera, but this is how far I wanted to take the repair, that you can actually plug this board in, push the power button, and it actually turns on. That was my goal for this in a technical version, to see if you could make this work. Theoretically, we did make this work, but I wouldn't trust it. So yeah, I hope you learned something in this video. All of my tools are linked in the video description as always. This was Mainboard Medic. Thank you very much and goodbye.